Hey folks, today's topic, we are talking about rates of change and particle motion part 1. So particle motion is one of these guaranteed topics that you'll see multiple times on the AP test. So it's a big portion. This is the intro to it, and then when we get into integrals, we'll see the second part of it. But anyway, let's start to review a couple of things. So let's review f of x versus f prime of x. So f of x represents quantity. We also call this what? Hopefully you remember this is what we call the point machine. You want some points, you plug x into f of x, gives you points. And we also have this thing called f prime of x, or df over dx. Remember, that means the same thing. This is just, is this Euler's notation? Yeah, this is Euler's notation, and this is Leibniz's notation. This is what we call a slope machine. If you want slopes, you plug things into the derivative. Now, we talk about f prime, we talk about the slope machine, but a better way to think about it is that it's really the instantaneous rate of change. We call this the IROC. Instantaneous rate of change is the IROC. It's the derivative at 1 point, also known as the slope. At that point. So we have IROC, we have AROC. Just to do a quick review, AROC, average rate of change, that's delta y over delta x. That's where you have 2 points. And you find the slope in between those 2 points. The average rate of change fails us when we try to figure out what's happening at 1 point, because you can't use the slope formula with only 1 point. Okay, so most of the time we talk about our functions as being some sort of position or velocity function, but it can represent anything. That's kind of the beauty of calculus, is that it can be applied. For those of you who maybe want to go into a business field, you might have to take business calculus, because this idea of how things are changing really helps us to predict what's going to happen in the future, or at least give us an idea to try to make the best educated guess that we can. So let's kind of highlight this sentence here. I like this sentence. The derivative gives us a way to discuss how any of these quantities change, usually with respect to time, at a given moment. So you could be talking about the area of a circle, outdoor temperature, how much rain has fallen, people with disease. That's kind of fitting right now in the middle of our COVID-ness. But so the derivative gives a way to discuss how quantities change at a given moment. The derivative gives a way to discuss how quantities change, and I'm going to highlight this with usually with respect to time. The derivative gives a way to discuss how quantities change, usually with respect to time, at a single moment. All right, so let's try our first. This is our applying calculus in context. So the temperature, capital T, notice that we got to be a little careful here, because later on in the story, they talk about the time, little t. So you can have the same letter used in a different way, as long as one's capitalized and one is lowercase. The temperature T in degrees Fahrenheit of a cold yam placed in a hot oven is given by T equals F of T, where T is the time in minutes since the yam was put in the oven. So first thing that I notice, the first thing that I want to highlight, this right here. The temperature in degrees Fahrenheit, units, where time is T, minutes. These are units. And if you have units in your story, you must have units in your answer. So I love it when they give us a story without any units because we don't have to worry about it. But anytime that we talk about temperature, we also have to put degrees Fahrenheit after it. Anytime we talk about time, we have to write minutes after it. So if we want to talk about t equals 5, you lose a whole point. Believe it or not, out of 2 points for the whole problem, you'd lose one of those points because you wrote t equals 5 instead of saying t equals 5 minutes. And so that little skill, we'll work on that a lot throughout the rest of this year. But this is the first time that you really have to start to pay attention to it. All right, so now let's try to interpret what we see here. So we've got the temperature that's in Fahrenheit. We've got the little t, which is time in minutes. Then we have t equals f of t. So that's a big clue. That clue is telling us, that little t is equal to minutes. And that's your x variable because it says f of x, f of t. So that's how we know that t is the x variable. And because f of t or f of x is always equal to y, we know that big T, which is degrees Fahrenheit, is our y coordinate. So usually you want to try to annotate that so that you can remember. Oh, I don't like the way I wrote that. I'm going to scribble these out and I'm going to draw them in a different color because it's not degrees f of y. It's degrees f. This is my x, and this is my y. I like that better. Okay, so we in a complete sentence with units. I'm going to underline that because it's such a big deal. Again, with units. Now, most of the time they don't tell you with units. You have to know what this means. Translate the practical meaning of the equation f of 2 equals 225. So now let's go back and apply this to what we just figured out here. Who is in the x position? 20 is in the x position. For us, that would be t. This would be little t, and then this would be big T, because that's my y value. F of t equals big T. Okay, so what does this mean? This means that my little t, which is time, is 20. So at 20 minutes, the temperature of what? The temperature of the yam is 255 degrees. So now let's try to write this up. At time, t equals 20. All right, notice a couple of things here. I put what the variable stands for in front of it, and then after it, I want to put the units. At t equals 20 minutes, the yam is at a temperature of big T equals 255 degrees F, degrees Fahrenheit. So notice a couple of things. This is a lot more fancy than just writing if t equals 20, then let me write that down just to show you sort of the difference of what I'm talking about here. If t equals 20, then big T equals 255. Back in Algebra 2 or even in pre-calc, this probably would have been enough. This would be enough. And I know what this means. You know what this means. But it's not good enough for what the College Board expects. They expect us to take it to the next level. So notice, in front of the little t, we say what that variable stands for, and then we put units. In front of the big T, we say what that variable stands for, and afterwards we put units. Okay, so what is the sign of f prime of t and of f prime of little t and then y? So let's start off by kind of discussing what does this mean. Okay, so f prime, that's our slope machine, and a slope machine finds the instantaneous rate of change. So this is finding this what's happening at f prime of t is equal to the instantaneous rate of change for all t. So it's telling me how is the y value changing according to the x value. So for us, that would be delta big T over delta little t. Now we can't calculate this at a single point, but this is just asking what this is just talking about what this notation is trying to find for us. So f of t, this is the I'm going to call it the IROC. I don't know if that's actually right, but I think it can't be the AROC because we don't have 2 points. Maybe I should just call it the rate of change and not have an I or an R in front of it, but I'm going to go with this. It's the IROC of big T per little t. I don't know if that actually helps or not. So f prime means the change in y over the change in x, all right? So, okay, so what does that mean for this story? What is the sign of the change in temperature over time? So what's happening? Remember, temperature is not the temperature in the oven. The oven is already hot. This is a huge hint. This little word here, you wouldn't think it's such a big deal, but it is. It's a cold yam placed in a hot oven. Now, this is the part of, you have to read this stuff to interpret it. So if I put a cold yam in the hot oven, what's going to happen to the temperature of the cold yam as minutes go by? It's going to increase. So what's going to happen to the change in temperature over time? F prime of t is going to be greater than 0. Now it says why, so we have to explain. Because the yam is cold when placed in the oven. What are the units of f prime of 20? Now look at the difference between these two scenarios. This is the derivative at all times t, or at any time t. This is the derivative at specifically time equals 20. So let's see what that would look like. So let's try to write down the units again. So I'm going to break this down according to what this stands for. F prime of any time is going to be equal to change in big T, change in temperature over change in time, which is equal to, now if they're talking about the units, let's just look at these units. You guys do this in chemistry, I think it's called stoichiometry. It's where you analyze the units of a situation to help you figure it out. This is the same thing. So I want to see the change in temperature. Well, how does temperature change? What's that measured in? It's measured in degrees Fahrenheit. As time changes, how is time measured? That's measured in minutes. So f prime of 20 is going to be the change in degrees Fahrenheit per minute when the time t equals 20 minutes. Okay, let's try to write that up. So f prime of 20 represents now I like to say what kind of rate of change it is whenever I can, and because this one was confusing to me because there's t in there, so I still think it's a instantaneous, but this one's definitely an instantaneous rate of change because we have our time at specifically 20. So f prime of 20 represents the instantaneous rate of change. Now, in my class, you can write IROC if you want. For the AP test, you should probably write at least INST period ROC, but I would write it out if I was taking their test. F prime of 20 represents the instantaneous rate of change of yam temperature. So it's saying how fast is the yam's temperature changing at time t equals 20 minutes. All right, so the first question is, what are the units? So, well, it doesn't say what it represents, so I guess this is just kind of an explanation. F prime of 20 represents the instantaneous rate of change of YAM temperature at time equals 20 minutes. So, the units are change in temperature, delta, or degrees Fahrenheit per minute. Maybe I didn't need to write all that stuff at the beginning. I guess it kind of explains where my thinking was. But I could probably have just gotten away with this at the end, which makes sense, right? You think about, you put a cold yam into a hot oven, what's going to change over time? The temperature of the yam per minute is going to change over time. It's going to get warmer. In a complete sentence with units, what is the practical meaning of the statement f prime of 20 equals 2? Okay, so now let's go back and try to annotate this so that'll help us understand what it's really trying to say. So this says f prime of, okay, inside of the x spot, so that would be little t, is equal to big T. So now what we know is that the time is 20, and we know that the temperature is 2. Now, wait. Oh, whoa, whoa, whoa. My bad. No. This is f prime. So this would be the change in temperature over the change in time. So what that means is how fast is the temperature changing at 20 minutes? That means the temperature changing by 2 degrees per minute at 20 minutes. So it's kind of weird. You'd think that that would always be the same. No, it's not. I mean, it probably, if you think about putting a cold yam into the oven, it probably warms up fairly quickly right away, and then it kind of slows down how fast it warms up near the end. So this represents, remember, the derivative. So what do we know? According to this, we know that the time is 20 minutes and that the rate of change of temperature per time is 2. So at time t equals 20 minutes, the yam's temperature is increasing by 2 degrees Fahrenheit per minute. So there's a couple of different ways you could write this up. I don't know if I want to get into all this right now. We might be better served later on, but I could also, so notice I added this word increasing. That's because the rate of change is implied here. If you wanted to, you could also write this up at time t equals 20 minutes. The yam's temperature is changing by 2 degrees Fahrenheit per minute. This is also okay. The reason I don't like to do this is because sometimes the temperature, sometimes things change, sometimes things decrease. The rate of change would be negative. So you'd have to remember to put the negative in here. What I usually do is I change this word increasing to decreasing and then leave this as 2 degrees Fahrenheit per minute. But I think both of them would be legal. Okay, so note the derivative, the units of the derivative will always be the y-axis over the x-axis. This is old news, right? I hope this is old news. The units of the derivative will be y-axis over x-axis. So that's the slope formula. That's why people like Leibniz's notation, because it does, this is the slope formula, but we just do it in terms of the derivative. Anyway, okay, an ice cream company knows that the cost, C in dollars, ding, 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 alert, 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 warning, warning, units, An ice cream company knows that the cost C in dollars to produce Q quarts of cookie dough, yum, I like this better than the yam, cookie dough ice cream is a function in part of the number of quarts they produce. So F of C. Okay, so this is telling me at the end here. So this is all my annotating that I'm going to do. I'm going to notice that I have units, which means I need to have units in my answer. The second thing that I notice is that this then is my Y value, and Q is my X value. So C is the Y value, and Q is the X value. So if I were to make a point out of this, the point would be Q, comma, capital C. I recommend annotating like that. Maybe you can just look at it and see it. It's up to you. So if f of 200 equals 70, so here I am, I'm going to annotate again. F of x, well, we're not going to call it x because we didn't use x and y, but our x is q. So this is the q, this is the number of quarts, equals the cost, big C, in dollars. So if f of 200 equals 70, explain in a full sentence with units exactly what this mathematical sentence is telling us in the context of the problem. Okay, so the cost, there's going to be 200 quarts that are going to be made, and the cost is going to end up being $70. Okay, so let's turn the cost. I think I'm going to change that a little bit. I'm going to say to produce 200 quarts of ice cream, comma, the cost would be $70. I was thinking about, there's a lot of different ways we could say this. We could say the cost to produce. I could say the cost at the beginning. I like to put the variable with the, or the word as close as I can to the number that it's associated with, but I could have also said the cost to produce 200 quarts of ice cream is $70. I could also say you would need $70 to produce 200 quarts of ice cream, something like that. I like the way this is written up because it puts the X before the Y, but it's up to you. Okay, if f prime, okay, here we go again. This is a change. This is a rate of change. This is an IROC. This is an instantaneous rate of change. So let's first figure out what the units would be. So f prime of q would equal change in y, which would be delta c, over change in x, which would be delta q. So our units would be dollars per quart. Okay, now we know what that stands for. So this means when x is 200, so when the number of quarts produced is 200, the change in cost per quart is $3, and it's positive, so that would be increasing. So explain in a full sentence what this is saying. All right, so we would say, actually don't. I think I like to write what's happening to the y value first. The cost, big C, is, you could just say changing here, but I'm going to say increasing by $3 per quart when Q equals 200 quarts are produced. If you drop that Q there, you could get away with this. You could get away with it. That would be fine. That would be fine. You could just say when 200 quarts are produced. If F double prime, okay, here we go. Now, this is the IROC of an IROC. So this is the instantaneous rate of change of the instantaneous rate of change. So F double prime of Q would equal to, all right, so this is going to be the rate of change. This would be F prime's units over Q. So what did we say F prime was? That was the rate of change of dollars per quart per quart. So remember, F prime is how fast the first derivative is changing, which is the change in y over the change in x. And then we're taking that change and we're looking at how that is changing according to another change. Now, the way we usually will write this up is dollars per quart squared. I'm just going to write Q squared. We usually just write squared at the end of it instead of writing it this way, because when I flip and multiply, I'd put this over 1. I'd put this over 1, I'd flip it up, and it'd be 1 over quart again. So it'd be dollars times quart. Quart times quart is quart squared. Okay, so at 200, let's think about what this stands for. This is our X. So we're making 200 quarts again. That means that the change in cost now is decreasing by, okay, so let's try to write it out. The change in cost is decreasing by, because it was negative, $0.1 per quart squared. I want to add a little bit more here because I didn't talk about when this is occurring. The change in cost is decreasing by $0.1 per quart squared when 200 quarts are produced. All right, so here we go again. I'm going to try to encourage you to pause here and try to annotate a little bit on your own and see how much you can add to this story. So pause and try just to annotate the top. See what you figured out. Okay, let's see how you did. So let F of t be the amount of rain in inches. Boom. That's a clue. That means I have to have units. And hours, that means I have to have units. Okay. Let F of t be the amount of rain in inches fallen since midnight, where t is the time in hours since midnight. Okay, so they start measuring at midnight, so that's important to think about. They start measuring at midnight, and then time is what changes, and then they measure how much rain has fallen. So if we say f of t, well, f of t means that who's in the x spot is little t. So little t is equal to time, and I like to put units with it. This is measured in hours. F of t is equal to the amount of rain that has fallen, that is in inches. Then I like to identify who is my x and who is my y. That means that since it's f of t, then little t is in the x position, so little t is x and big T is y. So if I were to make a point would look like t, comma, let's call that r. I'm going to also call this r. I could also have written TF of t, by the way. That would have been fine. Okay, so what does this mean? So first of all, let me point out that this is just a point. So this is my little t. This is my r. Actually, I'm going to go up. I'm going to change this for next year. Sorry. This is just for myself. F of t equals r, which equals rain per inch. I'm going to have to redo all these notes next year. That's exciting. My heart is not breaking right now. I'm not crying on the inside, I promise. Okay, so I know that time is t, and I know that the amount of rainfall is 3.1. So I like to write it up that I like to write the statement and then say when. So I'm going to write it up like this. 3.1 inches of rain has fallen when at time t equals 10 hours after midnight. I think I am going to go back to when, because that's what we're going to use. When time equals 10 hours after t equals 10 hours after midnight. That's the way we're going to write it up when we do our particle motion stuff. All right, let's look at the next one. F inverse of 10 equals 16. Okay, so now we're going to have to come back up top and write a little note to ourselves. Let's talk a little bit about what does this mean? What does F inverse? Actually, let's put it right underneath it. So F inverse always means swap your X and your Y around. So change those two values. So this would mean that our point, this is a point again, but this time our point is the inverse point. So this time our point would be r comma t. So if I go back up here and I look, this would be my r value and this would be my t value. All right, let's see if you can do the write-up on this one. Try to think. I know I'm throwing a little bit at you here without doing an inverse with you, but just try to write it up on your own, and then if it's wrong, we'll just scribble it out and write a new one. Hit a pause here and give it a try. Okay, so things have switched around. So in this case, I like to always do the y value before the x value. So this is my y value. So what do we now know? That time is 16 hours after midnight. And we know then that 10 inches of rain has fallen. So I'm going to write it up that way. If it is 16 hours after midnight, it'd be helpful if I could spell midnight, then I'm not going to say, sorry guys, sorry. I'm going to take out the if, and I'm going to replace then with when. It is 16 hours after midnight when 10 inches of rain has fallen. And I know it looks like I'm being really picky about this. I'm not going to grade that picky, okay? I just want to try to write this up as best I can, as close as I can, I'm sorry, to what you're going to see when we actually have to do it with particle motion. So that's why I'm making some slight changes. I hope it sort of makes sense. You can ask questions, of course, as we're going through. All right, so now what has changed here? How is this different? Well, these aren't points anymore. What are these? Hopefully you said that these are IROCs, because they are. They're instantaneous rates of change. Get a good color here. I guess I'll go with brown, one of my least favorites, but this is an IROC because it's a derivative. Okay, so this is an IROC, which means we have to now figure out what the units are. F prime of little t is equal to, okay, so the change in y, so this is the original function, not the inverse, which we'll talk about over here. This is the original function, so that's where our point was t comma r. So if I want to figure out the rate of change, it's the change in y over the change in x. So that would be delta r over delta little t. Delta r is measured in inches. This is measured in hours. So now we know what the units are going to be. So this is telling me the t value. This is telling me the time. And then this is telling me the inches per hour. See if you can write it up. See if you can write it up. I know it's going to be tough. Just try your best. Okay, let's see how you did. No, you don't have to say it perfectly like I did, but as long as you have the same gist of it, you're good to go. The amount of rain fallen is, okay, so this is a rate of change. This isn't, I'm just not going to just say the number. You could say the word changing if you wanted to, but I always like to say what it's doing going up or down. It shows that I understand a little bit more what's happening. So this is telling me that at 8 hours, the amount of rain that is falling is changing, is increasing by 0.4 inches per hour. So as time's going on at 8 hours, the more rain is falling. So the amount of rain fallen is increasing by 0.4 inches per hour when time t equals 8 hours after midnight. The amount of rain fallen is increasing by, notice I've got units on everything. I've identified what my variables are. I didn't do that up here because I didn't put a variable in there, but I did say what the 0.4 stood for. It was the amount of rain fallen. So let's see if you can let's do 2 pauses in this one. So I'm going to give you a second to do a pause here and try to identify this stuff, and then unpause, and then we'll pause again when we try to write the sentence. Okay, so first of all, this is an IROC. It's a derivative, so it's an instantaneous rate of change. We would say that F inverse prime of, okay, now that means that the letters have now switched. So instead of being T comma R, it's R comma T. So this is an R, which means if I'm going to figure out of R, that means I'm going to do the change in T over the change in R. So the change in T is hours, change in R is inches. So it's hours per inch. So this is a number of how we are changing hours per inch. Okay, so let's try to write this up. So 5 represents the amount of rain that has fallen. So if, let's try it like this. Let's try it like this. The time is, okay, are we increasing? Yes, the time is increasing by 2 hours per inch when five inches of rain has fallen. Oof, I struggle with this, guys. I struggle with writing these up. So if you don't feel like if you're kind of like, whoa, that was really hard, I'm on board with you. I'm on board with it. Okay, so we'll get into the story problems. It's a lot easier once we do the point. Trust me, when we do the particle motion, it you'll like it better. The word instantaneous is often used even when X does not represent time. The word is actually often omitted. So when they say rate of change, they almost always mean instantaneous rate of change. Now, if they want to talk about average rate of change, they have to say the word average. So when we say rate of change, most of the time it means instantaneous. So even if you're in a story like we're talking about the one we did, I'm not going to flip back to it, but the quarts of ice cream and then the cost, that didn't have anything to do with time, but we still consider instantaneous to be based on some moment in time, even if time isn't one of our measurements. So we might as well finish up this last one just to have it in there. All right, in economics, in October 1996, Hugo Rossi wrote, in the fall of 1972, President Nixon announced that the rate of increase of inflation was decreasing. Now that is quite a statement there. Let me highlight it. The rate of increase of inflation was decreasing. This was the first time a sitting president used the third derivative to advance their case for re-election. So let's talk about how we're getting all this. Why is this the third derivative? Well, if you think about inflation is based on money, right? How much your money is worth. So our function, I'm going to call it f of t, is equal to the value of money. How much is your money worth? Inflation means that the cost of like bread goes up, so that means that your money, $1 doesn't get what it used to before. So if you take the derivative of how money is changing, the value of money is changing, that finds this thing called inflation. So if I want to figure out how inflation is changing, I would take the derivative of inflation. So F double prime is equal to the rate of change of inflation. So he's said that the rate of increase of inflation was decreasing. So he's talking about I never can get this right. The rate of increase of inflation was So the rate of increase of inflation is this. Was decreasing, was going down. There we go. So it's the third derivative. I don't know. I always like to do this problem for any of you guys that are history majors or will go into economics. The decrease, so he says that he was saying that the decrease of the increase of inflation. So the increase of inflation would be the second derivative, and he's talking about the decrease of that change of inflation. So what's interesting about this is he's not saying that inflation was going down. Inflation is still going up in his case. He's even arguing the rate of increase of inflation was decreasing. So the amount that inflation was going up was going down. But you can read, there's a little story here if you want to read it to kind of, I'm sure Corpy can explain it a lot better than me.